Okay, the last thing, which is the most important one, is we can pattern match on case classes, right? So over here, we can do something like person match, right? And we can do, in fact, let me have a print line over here. It's time to have like a bit of space as print line. We're gonna say person, and we have name, age, and the is male thing, and we're just gonna, for now, we're just gonna say pattern matching works, right? And we already know that, you know, we can pattern match on case classes, so we see it over there, right? This obviously is not gonna work for humans. It's not gonna work for humans because humans are not case classes. So let's see, we have human over here and we have human over here. And let's see. Okay, so now it says object human is not a case class, so you can't pattern match, nor does it have an unapply or unapply sequence member. And this is the goal. This is why we're here. So it turns out that if the companion object of human contains a method called unapply, it doesn't have to override anything. It doesn't have to extend anything, right? So if it just says def unapply, right? And you don't see the signature here, but the signature should be, it basically should take in a human, right? And what it's returning is actually very, very interesting. This is going to get a bit complicated, so because what it returns is a structural type. So if we had a type like this, I'm just going to define it over here because types have to be defined in some object or case, in some object or class. So I'm going to have a type alias basically, right? Ignore the plus. It's a parameterized type, right? And if it has is empty, and it has you know, which returns a boolean, and it can return the actual element, right? Then if we use it over here, right, even though we don't have an implementation yet, then at least it's going to compile now. I'm sorry, why am I saying a? Going to say an answer of, in our case, we're going to return a tuple. So our a is going to be a tuple of string and boolean. So if we return a type that contains this structure, notice that it compiled, right? So now I just threw this exception, you know, this not implementing exception. But if we just remove that and we just say compile instead of run, so we see now it compiles. So basically what we see is that pattern matching already, you know, at least compiles as soon as we have a method called unapply. Oops, sorry. Right, so let's do this a bit more slowly, because it says human, right, with a capital H. Then an object that is called human must contain the function called unapply, which returns, in this case, we're pattern matching on you know, on three things, right? So it needs to return a tuple, right, surrounded was in a structural type that has is empty or get. So in order to implement unapply, and I know this is a bit complicated, but I swear to God, it's gonna make sense in a few minutes. We're going to implement a type which has a structure that looks like this. We're gonna create a new file, and we're gonna call it maybe. We're gonna have a sealed abstract class. We're gonna call it maybe, right? And it has to have the same structure, right? So it has to have this plus a, right? And it has to, and in fact, I'm gonna go back to human. And I'm gonna copy it. It has to have this structure. Now, so right now, like even though it's not necessary, but if I take this maybe, if I go to human over here, and if I return this, right, because it has exactly the same structure, it's still going to compile. For now, I'm not going to do this. I'm going to leave it as answer, but it doesn't really matter. The point is that we need to implement this now. So it's a sealed abstract class, and it will have only two implementations. It will have a final case class. Sure thing, you know, it's a maybe, right? So, you know, we have an answer. The answer is a maybe, and the first variant is going to be a sure thing. So it's going to be a very simple algebraic data type, or ADT. It's going to wrap a value. It's going to be extends maybe of a, right? This one. And it's going to override def get, which is just going to return the value, and it's going to override def is empty, which is a boolean, and it's going to be false. And which one did we have first? I just want to keep it like sort of in symmetry. You know, I actually prefer this one. Get and is empty like this. It doesn't really matter, but I just want to keep it in sync so that it's more clear for you guys. Okay, so we have the sealed abstract class. We have one variant of it, sure thing, and the other variant is just a case object. It's going to be not really. So we have a maybe, we have a sure thing, we have a not really, and it extends maybe of nothing, right? So this basically represents a value that is not there, right? So we're going to have def get, and it has to return an a. In this case, an a is nothing, right? Nothing, and it throws a new no such element exception. And again, we're going to have a video about exceptions very soon. And is empty is going to be true. We're going to have a boolean here, and we're going to have overrides because I prefer to have them. Right. So this is the whole thing. And for now, this is basically enough for us. So what we can do now is we can go to human over here, and we can remove this, and we can have an actual, you know, proper implementation. So I wanted to fit in the whole screen. So we're going to have if human equals null, then just return not really. Not really. And otherwise, just return a sure thing, right? And its value is going to be a tuple, right? Because we need to return a tuple with string and boolean. So in our case, it's going to be human dot age, human dot, I'm sorry, why did I start with age? We have name, we have age, and we have human dot is male, right? So this is enough for a compilation. We can go back to running now, and we will see that our last pattern match works now, right? It worked exactly the same as it works for the person. Like, for example, if instead of pattern match works, I'm going to change it in both places to print line A, for example, right? And we should see the 27, right? We see the 27 here, we see the 27 here. So now pattern matching works. So before we continue, I'm going to also have a companion object over here. And it's going to be called maybe, and it's going to have a factory called apply, right? Because it's a factory, it just takes in a value, and it's just a helper. It's just a helper basically to get rid of null, because classes like this are used to get rid of null. So if it's a null, then it's a not really. Otherwise, sure thing of value. So the last thing is going to be empty a, which is a maybe of a, which is not really. So what's happening? Simple typo, right? So when I was planning the script for this video, I actually planned to to play around with this first and then to implement the unapply method, but I kind of forgot. So what we're going to do now is we're going to actually do this right now. So I'm gonna, what we should do, I'm gonna duplicate this one. I'm gonna say code 2, right? Because this thing is just called code, so we can just play around with this. So we can do print line sure thing of 1337. We can print out not really. Let's see if it already works. Yeah, so we see the sure thing, we see not really. Now we can do print line sure thing of null, and it's going to be a sure thing of null, but we can also print out maybe of null, and it's going to automatically convert it into not really because we implemented this this helper thing, right? We can also see the empty one. We can see maybe dot empty. This is going to be an empty of any, and this is going to be an empty of string, but we're not going to see it in the implementation, and it should be exactly the same as, I'm sorry, I pressed page down accidentally. So all of these last ones, they should be the same as not really. It's like this one. In fact, let me do this, right? So these are all the same. Okay. So the thing is that what we implemented right now, this whole maybe thing, it already exists in Scala, and it is called option. So what we're going to do now is I'm going to go here, and I'm going to remove the whole maybe. In fact, let's go here and remove the entire file. I'm going to delete the file, right? And it's not going to compile in a bunch of places, right? Because sure thing is called some, and not really is called none, and maybe is called option. Maybe is called option. So now where do we have it? We have it still in human. In a human, we have over here, we have an option, In fact, this one can remain the same. We can have it like this. So this one is none, and this one is some. So as you can see, it looks exactly like this. And because option already exists, we can use option over here, and then we don't need to even create this thing, right? And option is very much, it used like all over the place in Scala. Like for example, it's basically there to represent a value that is absent, right? It's an optional value. Every canonical example is if you have a set of Bob and Alice, right, and you find the one that is equal to Bob, you're gonna see an you're gonna see a compilation error. What's happening is not a member of unit. Oh yeah, this one over here, like that. All right, so what you can see is some Bob, and if you try to look for Frank, you're not gonna see it, right? So it's none, some Bob and none. So basically the return type of find is an option, and in this case it's an option of string. All right, so we're pretty much done with our example. Let me remove this whole thing and have our code again over here. So look at this. This is gigantic file, human, right? With the copy method, it extends product, and by the way, it also needs to extend serializable, which is just a marker trait, which basically means it tells the JVM that instances of this class, they can be persisted, they can be saved to disk, they can be safely saved, they can be safely sent over the wire because they can be safely converted into an array of bytes, right, into a bunch of bytes. Look at this. This tiny, basically freaking one-liner is actually, if you were to implement it, it contains like almost 70 lines of code. I'm sure it's, sometimes formatted like, a bit too long. Like if we do this, then, you could save a few lines, but still, like, it's a lot. It's a lot of code, right? So what we're going to do now is I am going to comment out the entire human. I'm going to comment out the entire main, right? So the only thing that we have left is just the person, right? So we have just the person, which is this tiny case class. And I'm going to go to the build file, right? And by the way, we can stop this thing. And what I'm going to do is I'm going to add a Scala compiler option. So I'm going to say Scala C options plus equals. So if you add an option -x and then print colon and then typer like this, we reload the project, right? And let me press Control L so that it clears the screen. So if you compile now, it will print out what the typer sees. So what I'm going to do now is I'm going to maximize my terminal. I'm going to copy all of this. It doesn't go up. Does it go? Can it go down? Can it go down? Yes, it can go down. All right. So I'm going to copy that. I'm going to minimize it again. I'm going to paste it in Sublime. I'm going to maximize Sublime now, right? Like this. I'm also going to change the syntax to Scala, right? So now you see what the Scala compiler generates, and it should be very, very close to what we did. So you don't have to go through this in detail. You can do it on your own if you want. But basically, this is these two are the name. This is the age. This is the Ismail thing. This is the constructor, which looks similar to how constructors look in Java. This is the is female, and this call to dot unary is basically the bank, which negates the boolean. This is the copy method, and now you see how the default arguments are implemented in Scala, by the way. This is the product prefix, which is person. Product arities 3. The implementation of product element is like this. We have our product iterator. It's not really important how it is implemented. We have the can equal, which is whatever argument comes in. Is it an instance of person, which is the same as we did. We have the hash code, which is a bit more involved. Basically, it starts with some seed, then it calls some static methods on the class called on the object called statics. In fact, I actually looked it up. Look at this. So if we open statics, which is a statics.java, by the way, even though it's in a Scala standard library. So what we're calling here is this mix function, right? So if I go back to my VM, what is being called here is the mix function with the hash of name. And it's called again, and then it's called again, and then finalize hash is called. So we can go back to the browser. You see it over here. It's mix, and you have finalize hash over here, which calls avalanche, which swaps around some bits, And yeah, it's just crazy. This whole thing is Java code, by the way, as I already mentioned, right? It's .java. We don't really need to understand exactly how hash code is implemented. All we need to know is that it should be computed fast, and it should be identical for you know, same looking objects. Let's continue. So the toString is some fancy implementation. Now the equals is interesting. So the first thing that they do over here is they compare the references, which is done just for performance reasons, right? So we can go back to human if we wanted to, and over here we could say other dot is as instance of human, is it the same reference as this, or do this whole thing. And this is what they did over here, right? So this is what they did over here. So they just there's just a cast. Oh, they did it the other way around. They did it like this. Like I said, this equals to other instances of human, blah blah blah, like this. Okay, so they did this, and then they have the match, right, which looks kind of weird. It's basically, hey, it does a type match, and they cast. So if the type match, then they cast it to person over here, because this one is an any, right? So this $1 is an any, so they cast it to a person, and then they basically compare everything. Name equals name, age equals age, is male equals is male, and there should be somewhere. Where is it? Where's the can equal thing? I don't see it. Can equal. Huh. That's interesting. The last time I did it, it was also over here. And they were also calling can equal. Oh, maybe it's because it's final. That's interesting. Let's go here. Where's our person? If I remove final, right, and if I do this again, yeah, here, look, can equal. So in the equals, they actually call can equal. So this is exactly what I meant. This is only for the cases where you want to create your own hierarchies. Otherwise, you actually don't need that. Okay, let's go back to Sublime. So what we have here is okay, yeah, so we're done with the class. Now we only have the companion object person, which, you know, it has a constructor, you know, similar like in Java. We have the toString, which is just person. We have the construct, you know, the apply method, which constructs a person, and we have the unapply, which does the same thing. So if it's null, then it returns none. Otherwise, it constructs a sum and basically returns a tuple. Which is why, you know, we refreshed our knowledge about tuple, which is why we learned about options and so on. So essentially what we learned in this video is that you can pattern match on case classes because they have this unapply function, which makes the companion object of the case class, right? This object over here, it makes it a so-called extractor, right? So as soon as an object contains the unapply method, then it becomes an extractor. And it's called an extractor because it allows you to extract values out of human in this case. So what you can do basically now with this knowledge, every time you have some sort of data structure, you know, which is not a case class, let's say it comes from Java, let's say it's a string, right? You can implement your own kinds of pattern to match on that string. And in fact, this is what we're going to do now. First, we're going to create a new file, and we're going to call it file.scala. And let me minimize Sublime again, because otherwise it jumps around. Let's actually go to build, remove this type, or we don't need it anymore. Reload the project. Right, let's do the run thing again, and there is no main method because I commented everything out. Let's comment everything back in. We're not going to play with this example anymore, so we're going to duplicate this. In fact, we can actually remove everything over here. Remove everything over here, like this. Okay, so we have our code, and over here we're not going to do anything yet because we just created the. We can remove this thing. We can go to file, right? So over here we're going to create an object file, which is not going to be an extractor for now. All it will have is it will be able to construct a file location. Let's say we give it a location, we give it a name, we give it an extension, which is a string. Let me maximize it for now. And what it will return is it will return a string. So all it will do is construct a string interpolated string just with the location. Then it will add the slash, it will have the name, then it will add the dot, and it will have the extension, right? So for now, this is all we need. So we can go back to our main method. In fact, let me close all the others, close tabs to the right. Okay, so we can go to our method. And what we can do is we can construct strings like this, right? It's just a string, okay? And I'm gonna right click on Sublime, and I'm gonna say copy file path, and I'm just gonna paste it over here. So this is the path of the current file, right? So we're in homeblad, dav, scala place, source, main scala, main.scala. And we can also, let me maximize Sublime, do it a bit more explicitly, right? So we can also construct the string by just calling this apply function on the file, right? We can say location is, let me copy it out. It's this one. That's the location. And the name, not val name, the name is main, and the extension is not dot scala, scala, right? So if we have this, and I forgot the commas over here, right? And now what we can do is we can print them out. We can print out this one, we can print out this one, and we can also compare them, right? So we can do a print line, implicit file equals explicit file, and we will see that what is being constructed is exactly the same thing, right? And by the way, I just realized that we actually don't need this. We can do like that, right? Like this. This should be enough. So now what we want to do is we want to be able to pattern match on the string. So what we're going to do here is we're going to do def unapply. It's going to get some path, and it's going to construct an option with a tuple, right? It's going to return a tuple string, 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 right? And it's going to look like that. So we're just going to say if, let me maximize it actually. Okay, so we're going to say if path is null, or path is empty, then just return none. Otherwise, and this is where we'll have to deconstruct the path. So we're going to do last index of slash equals path dot last index of, and it takes a string slash. And then we're going to do last index of dot equals path dot last index of dot. Okay, and now we're going to have a location, which is a path dot substring. We're going to start with a 0, and we're going to go to the last index of slash, right? So this is basically until the last slash. So we're cutting out the string until the last slash. So everything is going to be here until the very last slash, because the location itself can contain slashes, right? So we're taking this. This is going to be the location. This is going to be the name, which is path dot substring, right? We're going to start with last index of slash. We're going to take the character after that, and we're going to go until the last index of dot, right? So this is going to be between the last slash and the last dot. And the extension is going to be, whoops, like that. It's going to be path dot substring last index of dot, the character after that until the very end, right? So whatever is after the last dot. And now all we need to do is we need to return the sum with a tuple, right? With location, name, and extension, right? So assuming that this compiles, and it did, we can go over here, and now we can pattern match on both of them. It doesn't matter how we constructed them, right? Because it's just a string. So let's take, for example, implicit file match case file, right? And we're going to do L and E for location, name, extension. And we can do, for example, print line location, $L, and we're going to do the same thing with name, and we're going to do the same thing over here, extension, like this. And in fact, maybe let's do that so that it's more pretty. Let's see. Look at this. Let me comment out those print lines. Maybe not the first one. I just don't want to have this one or this one. Look, so now it went and it extracted all of these, right? So let me have a empty line here. So it went to that string, it completely deconstructed it, right? And it extracted the information that we needed. It extracted the location, it extracted the name, it extracted the extension, and it works with both of them, right? It works with an implicit file and it also works with an explicit file, right? Which is kind of cool. So what happens in production, like usually like in reality, somehow extractor is not being used that often. I'm not really sure why. I guess it's because case classes are like just so convenient, right? So if you go to file, usually what you will do is you will just go and create your own case class file, right? And you will just have basically what the apply is doing. You're just gonna have location name extension. I'm gonna have it over here. Yeah. Like this, like that. Location name extension, right? You would just go here and you would override to string. It's just a string, and the implementation is going to be this, right? So instead of having this apply, you will just have this case class. Now, what you will get for free is going to be, this constructor extractor, right? And by the way, this doesn't compile because I said over here that it produces a string, but now it actually produces a file. So now, if you use the explicit file, you can match this thing, and if you use the implicit file, you still match this thing, which is kind of cool. So this is what developers tend to use, but as I mentioned, it's always trade-offs, right? So maybe don't jump straight to case classes right away, because all you needed over here was basically this, right? So how to construct a file-looking thing out of a string, right? Okay, so we're almost done with the video. There are only a few things left that I want to show you. Is the first one, the unapply function. It doesn't need to return an option of something, right? It can also return a boolean, right? So we can have a completely different extractor over here. We're gonna call it object is location longer than 20 characters, right? And we're gonna have def unapply. It's gonna take the path. And now it's not going to return an option, it's going to return a boolean. All it will do is pass.length is it bigger than 20, right? So now we can copy that. We can go to main, and over here we can also do this. We can do case this, and you need to have empty parens over here, and I can say print line yep, right? So now we're going to see yep instead, right? Because the location is longer than 20 lines. Okay, and the last thing is that now you see that there is a very deep relationship between tuples options and case classes and pattern matching. What you can also notice is that we have 22 tuples, and we also have 22 functions, and this is the reason over here. So I'm going to comment out everything. We are done with this example. In fact, I'm going to remove the example, right? So what we're going to have is a function 3, and this is the very last thing in this video, which got way too long, which is why I ended up splitting it in two. Probably, I mean, I haven't edited it yet, but I assume that I'm going to split it in two. Okay, so we have string and boolean, and it produces a unit, right? So it has some string, some int, some boolean. They're lowercase now. And all it's doing is it prints out the int, for example, right? So we have this function, right? And what you can do is you can construct a function 1. So this is a function 3, takes 3 things, produces a unit. What you can do is you can have a function that accepts a tuple, right, with the same signature, string and boolean, right, and also produces a unit. And you can create this function if you already have this one, right? So you can there's a function called tupled that will do this for you, right? So if you have a person, for example, person, I think we still have our person, I'm not sure. Let's see, person Bob, age 27, is male, equals true, and let's see if it compiles. Yeah, it compiles. We still have our person. Okay, so now we can call f1, right? Sorry. Come on, like this. We can call f1 with the companion object of person, right? We're gonna call unapply, right? Because we can call it ourselves, right? Pattern matching calls it for us, but we can also call it ourselves. And we pass it in our person, this one over here. So the return type of this is going to be an option of a tuple was a string, int, and boolean, as we had, you know, in this whole long video, right? And then we're going to say .get, so it's just going to get rid of the option. So now it's just a tuple of string, int, and boolean over here, right? Then we're passing this whole tuple to f1, and it should print out the age, which is 27, right? There we go. 27. So this is why you have exactly the same amount of functions and of tuples because of this. Because you know, there are you know, situations and scenarios where this is actually kind of useful. It's actually much closer to functional programming. In regular programming, you don't really have that. All right, we're by the end of this video. I'm sorry that I talk really fast. I'm sorry that it's really long. I'm guessing that I will end up splitting it into 2 videos. And yeah, so the important message of this is extractors are really cool. I'm not sure why they're not used that often in practice. Probably because case classes are just, you know, so really just so convenient. So what I'm asking you is basically don't slap the case keyword under your classes just because you're too lazy to say, you know, new person, right? That's basically it. Okay, so it's been Vlad. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.